Alright, good morning class. You're on to Mamu Jarvis, and this is our grade 10 experience. This morning we'll be looking at algebra, and we'll be looking at variation. Some people choose to call it variation, some will say variation. Well, however your mother tongue has turned your tongue, doesn't really matter. What's important is that you understand what we're talking about and the concepts. You have a strong grasp of the concept. So this is grade 10, that should be grade 10. And we'll be looking at variation. So what is variation? Variation essentially applies to an aspect of algebra that is concerned with the interaction or relationship between variables. Variation. And it's an offspring from the topic change of subject or formula. In fact, change of subject or formula provides a very good foundation for you to understand the matter of variation. It's one of the cheapest topics you can ever have in maths, and or would I say algebra. And it's very important that you need a bit of memorization here, because some ideas we may not be able to explain and tell you why it is this. So you really need to be able to say, okay, this is what you do at this point, and you just flow. Very straightforward. There are four aspects of variation. Four aspects of variation. Number one, variation one, we have what is called direct. We have what is called inverse. We have what is called joint. And we have what is called partial. By way of expanding further on that, the first two types, direct and inverse, would relate just two terms. Relate what? Just two terms. Don't bother trying to understand what that is for now. Just write that. I will explain as we come on more on this. So, the second and the third type of variation will concern itself with three terms. Or rather, the third concerns itself with three terms, and the fourth, which is called partial, will concern itself with just two terms. But we have a situation where a particular term is partly constant and partly vary with another. So this gives us a summary of the four types of variation or relationship you can have between terms. So let's start with the first one, direct variation. Like I said, it's a very direct topic, very, very direct, but you really need to pay attention to very sensitive details. Now, number one is what we call direct variation. So, what is direct variation? In direct variation, we are talking about, or we're considering two variables, x and y, and how they are related directly. When we say two terms are related directly, it will mean that if I increase one, it will cause an increase in the other. So, mathematicians, in trying to understand direct variation, we usually use a graph in this nature. A straight line graph increasing from the origin or from the left hand side and climbing on to the right. That's the simplest graph to show the direct relationship between y and x. And in this setup, you're going to have y directly proportional to what? X. Now, something you must take note of here. You would have noticed this term here. That term is what we call proportional. So anytime you see this term, we're talking about what? Proportional. How we write these terms now will dictate whether they are direct, inverse, joint, or partial as the case may be. But in this setup, y varies or y is proportional. So another word you can use for proportional will be what? Varies. Take note of this. So in some questions you can see y varies, you can say y is proportional to, they mean the same thing. So if I say y varies as x or y is proportional to x, what I'm saying is that as y is increasing, x is also what? Increasing. But that's not where the story ends. This is not very mathematical for us because it's just a relationship. So how do we now write it as a formula or as an equation so that we can relate with the variables? So for this, using this my diagram as a case study, y varies as x will be y equal to kx. I have introduced a constant or proportionality where k is the constant of what? Proportionality. K is the constant of proportionality. So what you have done is that you have replaced, watch this, in place of this, you have introduced what? Equal to k. Are we saying it? In place of this proportionality sign, because we want to make it an equation that we can relate with, we have now replaced this with what? Equal to k. So let's now play with this a little more. If I have written p varies as q, I would write that p is equal to what? kq. I have replaced this with what? This. For variation, except otherwise stated, we always use k as a constant of proportionality. Doesn't mean we cannot use any other thing, we can. But for purpose of simplification and everyone being on the same page when it comes to this topic, we would use what? K. So what's the first observation for you here? Take note that when you're giving a statement in this form, your first task is to change this proportionality sign to become what? Equal to k. Remember I said earlier that this sign means what? Proportional. And I'll say what? Varies. So in solving it mathematically now, I will now need to bring in something, a proportionality constant, so that I can now relate, because what is connecting this and this is a certain kind of value. So with this, we can now say that P is equal to KQ. What does that mean? Our first objective now will be to try to look for what? K. And from your knowledge of change your solid of formula, KQ will be equal to P. Is that not? And we divide both sides by Q, and K becomes what? P over Q. So that handles the knowledge of what? Direct variation. By the time we start solving problems now, you begin to understand the objective, because your first task is to try to identify what is called the connecting equation, or what is the equation or the idea connecting the variables. So we'll do that, we'll take some examples, and then we'll hit the road. Our textbook of reference is the New General Mathematics for Grade 10 or SS1, and that is found in chapter 18. So we'll go straight away to look at 18A and attempt certain exercises. Okay, so for our first thing, we have a question on... Okay, we have a question here on exercise 18A. That's in page 220 of our reference text. And it says, if 1 meter of wire has a mass of what? X grams. What will be the mass of 25 meters of the same wire? Now look at this. If 1 meter generates X grams, because the length of the wire corresponds to the mass, it will mean that if I have 25 meters, it will generate what? 25 times what? x grams. So what that means that 25 meters will generate 25x grams. That's why it's direct. As you increase this one, as you increase the length of the wire, the mass of the wire will increase. Let me use this practical example of to explain direct variation. As you keep growing, so your weight increases. Is that not? Yes, your weight will increase as a function of your growing. If you are, let's say, 15, 16 years of age, and you are weighing like maybe 10 grams, something is wrong. When you are not an inverse variation, something is rather wrong. When we come to inverse, we'll use another funny example to explain this. But as you increase in your growth, your weight ought to increase. That's what they're saying. So this will be equal to this. All right. Okay, so let's look at number 2. In question 2, we are told that 1 jar of coffee costs what? Y naira. So 1 jar costs Y naira. What will be the cost of 4 jars? So 4 jars will simply be what? 4 times Y, which means that 4 jars will be what? 4Y naira. And that takes care of number 2. In question 3, if a man cycles 15 kilometers in 1 hour, so in 1 hour he cycles 15 kilometers. Now it doesn't matter where you are writing it. You can write your kilometers here, you still arrive at the same answer. Now, I am now told that how far will he cycle in T hours? So in T hours, he's going to cycle what? 15 T kilometers. That's it. Because it's a direct relationship. If you increase the number of hours, we expect that the time, the distance covered will also do what? Increase by the factor of the number of hours you will spend. Now number 4, we are told that if eggs cost 25 naira each, so 1 egg is equal to what? 25 naira. Now the question is, how much will n eggs cost? So n eggs will cost 25 times n naira. We go to question 5. If a cup holds d millimeter, so 1 cup will hold d milliliter of water, how much will 8 cups hold? So 8 cups will hold 8 times d milliliter, which means that 8 cups is going to hold 8 d milliliters of water. And that's just as simple as that problem would be. In from question 6, we come into real interactive work in direct variation. So let's take question 6, and it says C varies as n. So C varies as n. You had a question there. For those of us who may want to flow along with this video, you may need to get New General Mathematics for SS1, this edition, the newest edition, and we are on page 220. So my approach to solving questions now will be to try to take each aspect of the question gradually. Now, you have C proportional to n. The first thing we said is to change this to what? Equal to k. So this will now be what? C equal to kn. That's the first thing you need to do. After doing that, you then make k the subject of the formula. So this means that kn will be equal to c. I divide both sides by n, and I have that k is equal to c over n. having said that, you are now told that C is equal to 28 when N is equal to what? 4. So what is K? K will now be equal to what? 28 divided by what? 4. And that will give you what? 7. Now, you're going to put this 7 back in this original work you're doing. You're going to put this 7 back in this original work you're doing. What is K? Is 7. So that means C will be equal to what? 7N. That is what we call the formula connecting the variables. Hear this. What you have gotten now is what is called the formula connecting the variables C and N. So in this setup, we are using C and N. This is the formula connecting the variables C and N. Please take note of that. See what we've done? We started by trying to convert to an equation form, and after that we try to obtain K. Usually the next statement made in the question is to enable you obtain K. Once you obtain K, you now have what is called a formula that you can always use. A formula that you can always what? Use. And with that formula, you may now be able to obtain C when a known value of N is given, or find find C when there's a known value of N, or find N when there's a known value of what? C. We are not required to look for, we are told to find, we're done with that. We're told to just find the formula connecting C and N. And this will be the formula connecting what? C and N. Okay, now let's look at question number 11. Let's look at question number 11. In question number 11, you are told that D, capital letter D, varies as capital letter S. Capital letter D varies as capital letter S. So the first thing you need to do is to write out your equation. That's the first thing you need to do. Without reading anything further in the question, try to write out the equation. That will be D equal to KS. And then the next thing you try to make K the summation of the formula. So KS is equal to D. I divide both sides by S, and K is equal to D over S. Once you've done that, you then look at the next aspect of the question that says that X, or rather D, is 140 and S is what? 35. So what would K be? That's the next thing you're trying to look for. You're trying to look for what? K. K would thus be equal to 140 over 35. For those of us who are used to using our calculators, you can easily get that this is what? 4. I don't need to do that because mentally I know that that's what my answer is going to be. Once I get this, I'm now going to resubstitute this here. Where I have K, I will now put what? 4. And it means that D is equal to what? 4S. Now let me make an observation here. This is one aspect of maths where as you're solving, you actually solving the question. The questions given to you is very direct. Because the question they will ask you is to find an expression or the formula connecting D and S, or find the connection between D and S, and that's what we have done. Now we come to the next phase. The next phase will be look for S when D is given. So if D is equal to 176, what would S be? You need to make S the subject of the formula here. You see that? So that will be 4S equal to D. So you discover that change of subject of formula becomes a critical topic you need to understand to be able to do this. So to do well here, you need to go back and study your change of subject or formula. So with this, I will have that what? I divide both sides by 4. S will now be equal to D over 4. What is D? 176 divided by 4. And if my math is in order, it should give me 44. and that will be 44 as the final answer. Okay, we're going to be looking at question 15 of that exercise, and I think that's the one that's a bit demanding because it was an extract from an excerpt from the JAM examination. Here it says x minus 3 is directly proportional to the square of y. Pay attention to the details. X minus 3 is 1/10. Directly proportional to what? The square of y. How do you write the square of y? Two details you need to pick out. So let's connect them together now. This is what it's going to be like. So that's what you're going to have. X minus 3 is proportional to what? Y squared. So you change this one now to what? I will advise you to always put this in a bracket, please. Always case it in a bracket. Equal to what? K y squared. K what? Y squared. Now with this, what do we do next? We make K the summate of the formula. So we rewrite ky squared equal to x minus what? 3. What's the next thing we do? We don't need y squared on the left hand side, so we divide both sides by what? Y squared. And what does that give us? K equal to x minus 3 over what? Y squared. So the next thing we need to do is to look for what is called the relationship connecting the terms. So what were we given? We are told that x is equal to 5 when y is equal to what? 2. X is equal to 5 when y is equal to 2. So what do? You're going to put x, 5 wherever you see x, you're going to put 2 wherever you see y. So k will now be what? 5 minus 3 divided by what? 2 squared. What is this? This will be 2 over 4. Or if I'm going to go with my usual pattern of saying 2 times 2, since I'm not a fan of calculators, and this will give me what? 1 over 2. So invariably, what you've done is to say that what the answer you've got here, you're going to substitute it back here. That's the objective. See, it's repetitive in nature. Same thing, just like playing your video game. Just keep doing it, keep doing it. In fact, it's one of the laziest aspects of maths you can study. Very interestingly lazy. And so this will now be what? X minus 3 equal to what? 1 over 2 y squared, which we can finally write as what? X minus 3 equal to y squared over 2. Now you can leave it like this. You can write y squared equal to x minus 3. I can also write this to be what? 2 into x minus 3 equal to y squared, meaning that y squared is equal to what? 2 into x minus 3. You'll still say the same thing. Nobody will penalize you. Remember we said that variation talks about what? Relationship. So whether you're writing one before the other is immaterial to the examiner. We want to ensure that you've written the relationship what? Correctly. Okay, having said that, the next thing you want to do is to check. The question says find x when y is what? 6. So we're looking for x. So x, y is what? 6. So how do you do that? It will mean that you have to make what? X the subject of the formula. So be careful. Some of us will come to this point and start to solve. No. You have an easier route here. See what you have here. I seen it. So what you have here, x minus 3 equal to 1 over 2 y squared. That's what I advise you to use. So it's x minus 3 equal to what? Y squared over 2. So what does that mean? It means that x will be equal to y squared over 2 plus what? 3. Is that not? So, but what is y? Y is what? 6. So that will be x equal to 6 squared over 2 plus what? 3. What is 6 squared? That's what? 36 divided by 2 plus 3. 18 plus 3. And your final answer becomes what? 21. So that's it. Very straightforward. But dealing with algebra, but we discovered that you're applying knowledge from your arithmetic. So that's the solution to that question. Alright, we'll close out for this, and in our next video we'll be looking at inverse variation. Thank you very much for enjoying this video with us, and we trust that you'll join us soon.